Hello, good morning, everybody. So today, we would proceed with the R for data analysis, video 6. So today we want to work more on sorting data. We want to work more on sorting a data set. If you have a data set, how do you sort the data properly? So when you say sorting things, means you would arrange things in order. So this function sorted is used to arrange data properly. You might arrange data from ascending to descending, or you can use it to arrange data from descending to ascending order. So let's work with the same MPG data. Let's call it. Maybe we still have it. We don't have it anymore. So we need to call the ggplot. So let's go back and see how we lose it. So we need to call these libraries again. So we install the tidyverse, loading. So then we'll call the ggplot. Then we install it. Then we call it. We call the library, and it's loading. Then we call library. Then we'll call the MPG. Now we have it. So if you want to view the data set, you can see it's the same data set we've been using before. And if you want to know more about it, so this is how to know. So today we're not gonna do much about the introduction. We already spoken about it. So we just want to sort data with it. So we use the arrange. Anytime you want to sort data, we use the arrange keyword. Remember my word, you pull the name of the data set, then the comma, then you pull. In most cases, try to put the comma next to the name of the data. So we want to work on the HYW, which is the highway miles per gallon. HYW, highway miles per gallon. So this is exactly what you want to arrange. So let's run it. It says there is no keyword called arrange. I hope we did not spell it wrongly. So we need to see where arrange function is, because in R, every key function is linked with a specific library. So we need to see, probably we did not run the tidyverse. Let's run the tidyverse. And there is another library which, yeah, I think tidyverse would do the work. I think I run the tidyverse, yeah. Okay, I did not run it, yeah. Okay, let me install it first. Let me install the tidyverse. Let me run it. So I think the arrange is usually work with tidyverse. So now we have it. So this is something about you need to be very smart. When you're running something and it's not working, it might be that you have to run a package, which it's in the package that you have the keyword you want to use in your analysis. So arrange. So now we've arranged the data, and we actually arranged the highway miles per gallon. So we arranged it in order. Now it's been arranged from the least to the highest. So we've got 12 and to what the highest is. So you can see now it's 12, but before we had it arranged in 29 and it's not been in order. So this is what we say when we say we want to sort data. So this and automatically, this arrange keyword, you would always arrange things in ascending. It is a normal thing. It's a norm to arrange in ascending. arrange in ascending. If you want to arrange it in descending order, then you have to be specific about how you want to arrange it. So we can do this. Then you run it before the highway, miles per gallon. You pull the descending keyword. It's not compulsory you write in uppercase. You can also write in lowercase. It's going to work. So now you have a second. To have a second parenthesis here. So arrange the data descending HWY. Now let's try to run it. So now it's arranged in descending. You can see now you've got the highest number is 44. Then here you got the list is 9. It's 12. So this is how we do when we sort data. And sorting in most cases usually work with integers. So you can also include a tiebreaker variable in a range. So you will notice that in Volkswagen Jetta and Volkswagen the new bitumen tie for the best highway mileage. So you can see this highway mileage is 44. So they're not very good. But this one's here, pickup SUV, they have a good highway, and you can see the type of car, Dakota pickup. So these are the ones with the very, so you can also decide to work with two variables at the same time. Now, let's say you want to compare two variables. Let's say, let's try to work with, let's arrange MPG. Then we want to have the HYW, the highway mileage in descending. So then you want to have another thing. We want to also have the TRY. So I mean the CTY is city miles per gallon. So you want to also have that in descending order. So we can actually work with two we can work with two so we can work with two variables at the same time. So I said that this problem is HWY, not HYW. That's the problem of programming. Once you write something wrong, it's going to tell you immediately. So now we've arranged HYW and CTY in descending order. So this is city miles per gallon, and this is the other one is the highway miles per gallon. We will see we've got Volkswagen Neo Bitu. It's got the highest city miles per gallon and also highway miles per gallon. Then we have the Volkswagen Jetta. It's got the same. Volkswagen Neo Bitu has got the highest. So Toyota Corolla also has got, that is the one with how many cylinders? 4 cylinder. So most of the 4-cylinder cars have a high, they have a high, they have a highway mile per gallon, which is really high. So, and we can also sort by function of a variable or variables. For example, suppose we want to sort MPG data according to the difference between the highway and the city gas per in descending order. So we just have to use it. So let's say, for example, you want to sort the data according to the difference. So you want to use a difference now. You don't want to use the, you don't want to sort them accordingly. You want to use a difference between the highway miles per gallon and city miles per gallon. So how do we do this? You use the same arrange. Then you call the data name MPG. Then you write or open it, you write a descending and open a parentheses. HWY, mind you want to use a difference, isn't it? Minus CTY. So this is mathematical calculations, and we have it here. So, and is already done for you. So this is 24, 36, 29. So now, as you can see, it shows you the values, which is, shows you the value, which is the difference between the two. The difference between the two, and it shows you the values in a very amazing way. So as you can see, the 2008 Honda Civic, the 2008 Honda Civic has the largest difference between the city and highway gas mileage. So the difference is very, very large between the city and the highway. So you notice the previous sort that there was no column that actually lists the highway / the city. So in the column before that, there was nothing like highway / city. But what would happen is once you do this, is going to actually, so a better practice would be to create a new variable. Because now, let's say, for example, you still want to check what the city miles per gallon is, and you want to check the highway, you want to compare it. You cannot do that anymore. So the best thing is you get another column for this calculation you made here. So you made it, you make a separate column for it. So then it says we're going to show you how to do that in the next video. So we will see how to do that later on, but for now we would like to move on to the next one, which is a pipe. So let's go on to the pipe. I told you the previous class that we went work on the pipe thing. So what is a pipe? So we often want to use two or more transformation functions. We often want to use two or more transformation functions in succession. So let's say, for example, you want to filter out the cars in MPG that gets less than 20 miles per gallon. That gets what? Less than 20 miles per gallon on the highway. And then you want to sort the remaining cars according to the engine size display. So the engine side displacement in descending order. Now you're having two things, isn't it? The first one, you want to filter the cars that is in MPG that is got less than 20 miles per gallon on a highway. And you want to sort the remaining according to the engine size in descending order. So there are a couple of normal simple ways to do this. So one of the ways to do it is you use the arrange keyword. Use arrange keyword. Then you remember we did filtering yesterday, isn't it? So you filter the MPG by what? By a highway mileage, which is greater than or equals to 20. That's what the question says. So you want to filter the cars with MPG that gets less than 20, isn't it? So that gets less than 20. You want to filter that out. You want to take that out of it. So what you would do is you would say, I want the mileage, I want you to filter for me. I want you to get me the MPG cars, which is got highway miles per gallon, which is greater than 20 or equals to 20. So the meaning is anything less than 20 is been thrown away. So this is the first way. So what else do you want to do? That you want to sort the remaining cards. After you've done this, you want to sort the remaining ones in descending order. In descending order. So how do you do this? So then you would say you will cover the parentheses. So since you want to do two things, you need to put each of them in parentheses and you need to arrange them. What would happen is I would explain to you after writing the code that you write a descending, open a parentheses of display. You want to put the displacement into descending order. Now, what you've done here, what the code says is this. It says arrange for me. Arrange for me. Before the arrangement, I want you to also filter for me. The MPG data, I want to filter out any highway mileage per gallon, which is less than 20. So the meaning is give me highway mileage, which is greater than and equals to 20. Then after that, I want you to arrange for me the displacement, the engine size displacement in descending order. So now we've got two things to do. Now let's run it and see. Now immediately you get your result. This is the power programming. Now we've filtered out, you would say now the YW is going to be anything 20 above. You would not see anything 19, whatever. So I go up and see HWY. You saw HWY, you saw HWY, HWY. We got 12, we had 12, we had 15. But now we sorted it, we filtered that out. When you filter something means you throw it away. You don't need it anymore. So now, after we've done that, then we put the displacement in descending order. So now we started from 7, 6.2. So this is displacement in descending order. So you start from the highest, then you go down, 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 down to the least. So this is a simple way to solve the problem. So now let's talk about how to nest functions, because what we actually did here looks a bit like a nesting function. But now I want to talk more about what I did yesterday here. How we did all these functions, because yesterday I was only trying to solve some problems with you, and I was using the nested function, which we did not talk. This is an example of a nested function. I will explain to you what a nested function is very soon. So nesting functions. Nesting functions. So now a nesting function is a way is often a good practice, because it becomes hard to keep track of parentheses. When the parentheses are too many, it becomes a problem. So when you have several functions you want to put together, it can become a problem for you to be able to sort things out properly. So a slightly better way to do that, which is, but it's not actually ideal, but it's a good way, is to perform one transformation at a time. Transform one thing and do the second one next time. That is the way I did yesterday. So storing the intermediate result along the way. So what you do is every time you sort something, you put that thing, you give it a name. Now, for example, when I did this arrangement and filtering, and it actually give this a name. So trying to give it a name will save you the stress of trying to do it all over again when you want to use the same thing you've done before. So instead of trying to do the same from the scratch, you've already had it stored with a name. You just have to pick it up from where you stopped and you continue with it. I'll show you an example now. Now, let's say we want to filter costs with MPG. The same thing we did here. The same thing we did here. Let's do it again using the nested function. So what do? We would say we would write a code. It would say filter, which was what we did, isn't it? So we said filter. Then we'll open a parenthesis. I want you to filter MPG. Then I want you to filter the H highway mileage per gallon, which is greater than and equals to 20. So I want to get that from my data. So that is first thing. So after you do that, then on the second line, you want to arrange. So you want to arrange, but this is what you want to arrange. You have to solve this before you arrange it. So that's why you need to give this a name. You need to give it a name, put it into a variable. So what is going to be the name we'll give it? Let's give it filtered underscore MPG. So then equals to, so now we've given it a name. So now if you want to arrange anything, you would arrange this filtered MPG. So how do you want to filter it? You want to filter in descending order, and you want to have the water cylinder filtered in descending order. Now I think it looks pretty good now. So if we run this, we're going to get the same result as what we have here, but it looks clean and looks more. Now it's told this for you. So you got 156 observation and 11 variables. So this, anytime you want to call this, you can easily call the name. You can say You can say, for example, you want to view it, and say view filtered underscore MPG. So when you say view filtered underscore MPG and you run it, so it's going to show you the data. So this is something, it's a very good practice for people who use or usually work with R. It's a good practice. So now we want to move on. So the approach you saw is it's going to avoid for example, we want to show you how to have too many things. Like all of this you have here, sometimes it might get really confusing. Although it's quite better than this, because sometimes when you have too much parentheses, you have a problem because you cannot really figure out where the bug is coming from. So the approach, the best way is to avoid nesting. So, but it's going to introduce what we call redundancy. So we're going to have redundancy, which is the name filtered MPG is introduced and then immediately used as an argument inside the arrange. So we use it and we use it exactly as an argument here. So this is what we call redundancy in programming. So what do? It will be much better if to combine these steps. We can combine the steps. So, and there is something good about tidyverse. That's why it's called tidyverse. It helps to tidy up your data. So it has a way to do it using a pipe. And that's why we want to work on when we work on pipe. So the pipe provides a way to bypass the need to name an intermediate data set. So instead of naming the filtered MPG, you're going to bypass it and you're going to use the pipe thing to work with it. So, and it's going to feed the data which you already filtered into the next transformation function in the line. So this is how we do it. Let me show you how to do it. So the way to use a pipe, now let me label this using pipe. So how do we use pipe? So the first thing is you call the data name. You call the data name. MPG is the data we're working with, isn't it? So you use a pipe. Pipe. So automatically it's going to indent it. So MPG, the pipe greater than pipe. So meaning I want to work with data code MPG. So every other thing you write underneath is the same block of code. So that's why I show you here that you cannot stop here because there are codes to remain set unexpected end of document. So this is not the end of the code. So now what is the first thing we wanted to do? We wanted to filter. We wanted to filter what? We want to filter HYW, sorry. We want to filter HYW. And what do we want to filter? We want to filter anything greater than or equals to what? 20. So you close it. Since you still have some other things to do, you would do the piping thing again. If you want to end here, it's fine. But once you put the piping thing, it's going to tell that you still have more things to write. If you fail to write and you stop here, it's not going to give you a good result. So when you enter again, now it tells you this is not the end of your code. You still have to write something. So the second instruction we wanted to do is to arrange what in descending order, what the cycle, the cylinder. So now we've done it. So it looks pretty neat now than what we had before. I wanted to compare this to this and to this. So it looks pretty good now, and you can easily track where your problem is if you have a problem. So now we've got what we wanted to get. So now we have a very clean data set and we have a clean result. So now we should be able to start with MPG, and we should when we read the data, when we read the code, we start with MPG and we'll feed in to the filter that will feed the output into arrange. So we would avoid nesting and introducing intermediate data set names. So this operator pipe takes a data set that precedes it and fits into the next fits into the function that follows it. This is exactly what it does. If you want to continue with another function, another thing you want to do, you put a piping thing. So the meaning of the piping thing is a pipe that is to say all the things I've done in the first one, pipe, send it through the pipe into the second one. So if you want to continue, you do the same thing. So this is what piping is used for. Now let's do some examples. Let's do some, or let me give you something to do. You can pause the video and do this exercise. I'm calling exercise. Exercise. Now I would want you to use the flight, to use a flight data. We need to call the flight data. What is the flight data? So flight data is in DeepL. So I think we already have it. Let me check. So let me call flights again. Let's call flights again. Okay, send flights. It still did not find it. Okay, then let me go and install the DeepL. Let me install it again. Install packages. DeepL. Okay, then let me pull the library. This is something you need to master with R. If you don't master this very well, you would have a lot of troubles. You get tired easily. Because when you're trying to do something and it's not coming up, you say, oh my God, what's this? Tired of it. But you just have to do something simple. So now the library, the PLYR. So now it's working. All right, so now let's call the flights again. So flights. Still did not say. Let's see if it's aiding in another. Okay, well, let's run the package that has the flights in it. So let's run these libraries. Let's run this, we're on this, and we're on this. I think, okay, let's reinstall this package. Let's reinstall the New York City flights because I want to give you some exercises to work with. So now I think we've got it now. So it's installing it. So let's install the second one, the Lahman, because we might need to work with it. So every day when you want to work with your libraries again or your packages, you will need to do this running thing again. So it's something that once you get used to it, it's not a big deal. It's only a big deal if you're not patient enough. Now I've got my flights. So now let's use a piping thing. What is the farthest airport flown by the American airline? What is the farthest airport flown? Do we have airports? Do we even have airports? You want to view the data, you say view flights. So let's view flights and see if we have airports given. So we don't have airports given. So then how do you know the farthest airport? How do you know? You're going to know the flight, which is, let's get more information about the flight. Let's get more information about the flights so to know how to solve the problem. So this is carrier flight number, origin, air, time. So this is air time, the time. Okay, this is distance between the airports. Now we have a distance. So we want to know the farthest airports flown. So which is the farthest airports flown? We need to know that by using the distance. So how do you do it? So we would use the method we just learned now. So which data do we want to work with? We want to work with MPG. So let's try the question. Use pipe to answer the following questions. So question, the first one says, what is the farthest? What is the farthest airport flown to by American Airlines? So American Airlines. So I think the first thing to do to solve this problem is to filter the American Airlines alone. So then the first thing to do is to call flights. You call flights, then you use a pipe, greater than pipe. So after you call the flights, then you want to filter the American Airlines first. So you want to filter the carrier. You want to filter the carrier. Say filter. Put a parenthesis. Carrier equals to American Airlines is A. So you want to filter American Airlines equals to A. Then after that, you want to filter. You want to filter where the distance. You want to arrange the distance in descending order. So then you say arrange the distance, descending, then distance. So this is a pretty, let me say a distance. So that would show you the farthest distance. So let's run it if it's gonna work. I hope we don't have problems. So we do not have a problem. We have a problem since I filter out. Okay, sorry. We use this, not single equals to. All right, now we have it. So we saw the filtering. We have only AA American Airline. And also we are in the distance in descending order. So where is the distance here? We can view it. So if you want to view it, you can give it a name because now I'm not seeing a distance here. So it's not easy for me. So, but we can, do we have the names of the airports actually? Origin. So let me give this a name. Let me say farthest. So let me give it a name. So that would be easy for me to see the old data. Let's run it. So farthest airport. So now we can view it. Yes, sorry. Airport. Farthest airport. So let's run it again. Correct the mistakes in it. So then let's view it. This. Now let's see. So now we would, how would do we want to see the farthest airport now? So we would see the time. So the farthest airport is, do we even have the names of the airport? That is what I'm trying to see. We don't have airport name. So we have a flight number, carrier. We don't have an airport. So the farthest airport flown to by American Airlines. Oh, we have origin. We have a destination that's San Francisco. So that is San Francisco. So the distance is 2,586. So this is 7 hours from JFK. The flight 59 with tail number 36336 AA flown flown the same distance in 7 hours, and these flown the same distance, flight 179 flown the same distance in 10 hours. So the hours differs, and they've flown the same airport. Actually might be due to many reasons. So this is called air delay, and this is might be the scheduled time. It might be many other reasons which we can look into. It might also be the size of the plane and many other things. So what is the farthest airport flown to out of LaGuardia? So what is the farthest airport flown out to? What is the farthest airport flown? Let's write it down. So the next question says, so answer to this is what is San Francisco. So it's SFO, San Francisco Airport. So that's answer. So, and there is another question here that's asking what is question. Let me write question number 2. Question number 2. Question number 2 is saying, what is the farthest? What is the farthest airport flown to? What is the farthest airport flown to? Flown to out of low LaGuardia, LGA by American Airlines. So AA is what we're still dealing with. So AA is what we're still dealing with. So we can use so we can let's try to see how we can do this. So now we want to know the farthest airport flown to out of LaGuardia. So in this case, we have to deal with two things. We need to deal with the flight out of. So we need to have a flight out of LaGuardia, which is LGA, the origin. So we need to have an origin. So let's filter origin LGA first. And we can also filter the flight name as AAA. So now let's filter two things here. So the first thing to filter is, let's go to let's use the piping thing to do it again. So the data we want to use is MPG, flight, sorry. The data we want to use is flights. So you write flights, and you write remember your pipe. Then after the flights, we want to filter airport, which what's the name? We want to filter origin. We want to filter origin because it said flown out from. So we want to filter origin. Origin is equals to LGA, right? Then we do the pipe thing because we still want to write some more codes. So now, then we want to buy American Airline. So we want to also filter. We want to also filter from it. We want to also, you can see program is not easy. Carrier. We want to also filter carrier, which is equals to what? Equals to AA. So now, then farthest airport flown to. We want to now, after we do this, then we're going to send the data into it. Can we send the data into another thing and do it once and for all? So we want to see the distance. You're going to now check the distance and the farthest airport. So farthest airport is going to be distance. Yeah, let's a distance. So now let's put the distance in descending order. So let's do the pipe thing, and we'll put the distance. We arrange the distance, arrange distance into what? Into descending order. You use another one here. So this is a very good practice. So you put all the things, all the information you want to get, you put in the same code, in the same block of code. So let's run it. I can say it's amazing how our functions. Then we can give this a name. We can say farthest airport flown. But which is the farthest airport flown to? Because you don't really see the data properly here. So we cannot see many things. So so what we can do is put all of this into farthest airport, uh, farthest airport out of out LGGA. So then you give it a value. So now we've got a name for it. So if you run this again, so it's going to give you the name. So we can now view this. You can copy this. It's too long actually, but I will just try to say we should have a way that would give us all the things we need to know about it. So now, so this is we're going to go to distance is the farthest, isn't it? So the farthest destination is DFW. DFW is the farthest airport flown to out of LGA. So these are all the flights that started from LGA. So where the flight was farthest to is DFW. DFW has got its own name. Things is I'm not very conversant with all the names. So DFW is the answer to this question. So the answer is DFW. DFW. So now you can see how powerful programming languages, and we're just starting. We're gonna see a lot of beautiful things about using R for data transformation. Now let's try one more question before we start this session today. So another one is saying, what is the most delayed flight during winter? What is the most delayed flight? Which flight is most delayed during the winter? So during the winter, January, February, and December. So these are the 3 months we want to work with. So what is the most delayed flight in summer? So then we want to also find the most delayed flight in summer. What is the most delayed flight in summer? So what is the most delayed flight in summer? So the summer, the months you're dealing with is June, July, and August. So how do you do this? This is the way you think. The first thing you do, if you want to solve a problem, you think about it. Now let's go back to the data itself. So how do you know a flight has been delayed? So looking at the table, you see uh arrival delay. And we also have departure delay. So we have arrival delay, we have departure delay. So we can actually, it didn't specify here. It's just saying what is the most delayed flight during the winter and what is the most delayed flight. So now we're going to work with delays, our arrival delay and departure delay. So that's the first thing we want to filter. So we would put that in descending order. Then we will filter the second thing in winter when the months are 1 to 12, 1, 2, and when the months are 6, 7, 8. So let's quickly, without further ado, let's solve the problem. So the solution to this problem is going to be, so the first thing we want to work with the flights data. You write your flights. Then you do the pipe thing because you want to send your result into the next stage. So then what do you want to filter? We want to filter out. So we want to filter out any result which is not January, February, March. So we want to filter. So we want to filter and get a result where a month is equals to, open a parenthesis. Instead of using this, let's say in pipe, month in this. So you open a parenthesis, 1, 12, 1, and 2. Then whatever you get from these, okay, let's do them separately. So whatever you get from this, you want to send into the next level. So whatever you get from this, you want to send to the second level. So you want to filter this data out. You want to see the flights which is been delayed. So what's the next thing to do? You would arrange the in descending order. Descending order. What? Arrival delay. R underscore delay. Then we can also do the same thing for the partial delay. So the underscore delay. So then are we done? There's a problem here. Unexpected token. I think is this. Yeah. Let's use this. Okay. Still not given the problem. So what I tried to do before is I tried to use this pipe in pipe. So let's just say data in this. But I try to use this because we're working with numbers, it's going to be in a matrix form. So now let's see if the code seems to make sense. So we're trying to filter the flights, and whatever we filter here, we want to filter the month, which is in 12, 1, and 2. That's December, January, and February. Then whatever we get from there, we want to arrange the arrival delay and partial delay in descending order. We want to see the most delayed flight. We want to see the flight which is most delayed. All right. So then we run it. So there is a problem here. It says must code what exactly arrange. So that means we cannot do this. So we would now try to do them separately. I was just trying to see if it's gonna work. So then we'll put comma, then you do descending. So this is, let's try this way. So let's try to see if it's gonna work with adding them together. So now it doesn't work that way, but it worked separating them. Now let's take a look at this data very well. So now you've got departure delay and you've got arrival delay. And the flight which is most is HA, which has got it's got 1,272 arrival delay, and it's got 1,301 departure delay. So the answer is what is the most delayed flight? So the most delayed flight is HA. It's HA. So the answer is HA. So this is how we solve a very big problem. So it's having a most delayed. It's most delayed. So there could be many reasons for that. So these are the months we have: 1 December, February. So you can see, so the most delayed flight is HA. Now let's go to the next one. Use the same code. We want to find the most delayed flights in summer, June, July. So you can use the same code. You can use the same code. You can just copy and paste it to make your life easy, not to waste your time. But mind you, whenever you copy and paste a code, there might be something wrong. So expect to have an error. So we have 7, excuse me, we have 8. So these are the months in summer. So let's run it, expect some errors. So, but we didn't have any error. And so 6, 7, 8. So the most delayed arrival is delayed departure is 1137. Arrival delay is 112. So this is the time, and the flight is MQ. So the answer is MQ. So now we'll solve the problem. So this is an amazing way to solve problems using pipe. I really hope you enjoy this session today. See you next time. Have a nice day.